Hello everyone, how are you all? Welcome back to Nilab's Tech Forge. Today we'll be making object detection using Raspberry Pi 5. So let's get started. Let's directly move to the parts required. So first of all, we'll need an SD card reader. An SD card. Here I'm using 64 GB for the best performance, so that 64 GB is more than enough so that we can store our models and everything. Then we'll need a Raspberry Pi 5. Here I have used 52 Pi cooler. So you can see this cooler. It keeps the temperatures really low. You can also go with the cooler, which official cooler of Raspberry Pi, named as active cooler, or you can continue without any cooler. The Raspberry Pi won't heat up that much. And the main part, will need a Raspberry Pi camera. So this is the official camera. The model name is Raspberry Pi official camera 1.3. Like the model is Rev 1.3. And we'll need a cable, flex cable, to connect the camera with our Raspberry Pi 5. Here I am using the official Raspberry Pi 5 cable, which uh, which is 500 in length. So this is very long enough, like I can use it in my other projects also. So let's get started. Okay, so first of all, we need to put our SD card in our SD card reader. Now I'll plug in this SD card in my PC. Now we can see that our SD card is showing. So now first of all, we'll need Raspberry Pi imager. Like if you have Raspberry Pi imager, you can just use that, or if you don't have, you can download it. You can go to your browser, you can search Raspberry Pi imager. You can go on the first link. Now here you can see Raspberry Pi imager. You can download it for Windows and then you can continue the setup. So right now I'll just use Raspberry Pi imager. Okay, so as we are going with Raspberry Pi 5, so we'll just say Raspberry Pi 5. Now the operating system, it has to be 64-bit. This Raspberry Pi OS 64-bit. Now we need to choose the storage. So yes, it shows my SD card, it is 64 GB. Yes, so now we can just click on next right here. So would you like to apply OS customization and settings? So yes, we'll do that, but first of all we need to edit the settings. So we have to set the host name, which I am setting to Raspberry Pi. We have to set the username, which is very important. Remember the username which you'll set, because we'll need that later on. And now we need to set the password, so I'll just keep it root. Okay, so we need to configure the wireless LAN, which is our Wi-Fi. So here we have to put our Wi-Fi's name, and here we have to put the password. Then we have to select India, because I live in India, and you have to select the country in which you live in. And here we have to do the time zone. And so now this tab is complete. Now we can go to services. We need to enable SSH, and this helps us to remotely log into our Raspberry Pi without using any external monitor. Like imagine using this PC, like this PC, and using Raspberry Pi OS, like connecting to Raspberry Pi OS and running commands through this PC on our Raspberry Pi. So we need to enable SSH. We can just set it to use password authentication. Then we need to go on options, eject media when finished, and it's optional, like you can do if you want. So now I'll just click on save, and now we press on yes. Okay, all existing data on this USB device will be erased. Are you sure you want to continue? So now we'll just click on yes, and we can see that it has started. You can just click on cancel. It's okay if it shows up any error, because our Raspberry Pi imager is already onto it and doing the job. So when it's just doing everything, we can just plug in our camera. So what we have to do, you see these small ports here. So these brown ports, here we have to put our flex strip. So I'm using this one. This is golden in color. But if you are using Raspberry Pi 3 or Raspberry Pi 4, like here I have a Raspberry Pi 3, you see there is one single port but it is very big. So in that case you'll need to use this wire. And remember that on this wire we have a blue part. This blue part should always face towards the HDMI port, towards this HDMI port. It's very important. And on this Raspberry Pi 5 we have this black part on the flex strip, and this black part should always face towards these two micro HDMI ports. And we have two of these ports. You can plug it in any of these two. So, and now moving on to the camera, the black strip on the camera should face away from the main PCB, like it should face backwards. Now let's just wait until it does its job. So these are all the notes of this project. You can just, you feel free to pause the video and check. So this is the hardware which I have already told you: Raspberry Pi 5, Raspberry Pi camera module, micro SD card, and a power supply. Ah yes, power supply. It is very important. Right now I am using this official Raspberry Pi charger. I mean, it's an adapter. I am using this official, and you have to make sure that you are providing enough power to the Raspberry Pi 5, because it disables the peripherals, like it will disable the camera if it is not receiving enough power. Optional but recommended. Case with camera mount. Okay, I don't have it right now, but yes, I'll 3D print one for my future projects. Heat sink and fan, I have already told you. Ethernet cable, HDMI and monitor. So we won't be using these because we are doing it in headless mode. We'll connect this PC with our Raspberry Pi and do everything. Software, Raspberry Pi OS Debian based, the one which I made you install. And then yes, should be, it must be 64-bit. And now after this everything, will start with the main project. So this is the hardware assembly, like it shows like we have what we have to connect where. So here I have mentioned that camera, connect the camera ribbon cable blue side away from the board. Let me just edit it. Blue side towards the HDMI or micro HDMI ports. Blue slash blue yes, blue slash black side towards the HDMI or micro HDMI ports. So connect the HDMI keyboard mouse again if you have a spare keyboard, mouse and monitor, and the power on the Pi. So once this is done, so then we can just move on to our simple setup. So this will be the code of our main, like, object detection. We'll be using YOLO V8 model, and it is like very good model. It can detect stuff like, let me show you, I have mentioned that also. Yes, it can detect people, vehicles, animals, object like bicycle, backpack, etc., food, furniture, electronics, appliances, indoor like book, clock, vase, scissor. uh, don't worry, I'll show it working. And this is the system specification, like this will be the output. So the video resolution will be 650 into 840 pixels. Frame rate, because this Raspberry Pi has very low computing power. It will be around 15 fps, and then confidence, like, just leave it right now. Model size will be using this one, which is S. So this S shows that it is a small model, like the small version of YOLO V8. So basically what this model does, that it's fast but not as accurate as large or extra large models, but yeah, we'll be using this. So RAM usage 1 to 2 GB. Here I have 8 GB variant of Raspberry Pi 5. So this is the next steps and enhancement if you want to take this project to the next level. Okay, so let's just move to the top, and don't worry, I'll be sharing this PDF with you, like these whole notes, and you can also find this code on my GitHub. Like, let me just show you. Google Chrome, github.com/nilab2020. So repositories, Raspberry Pi. So you can see this repository, Raspberry Pi 5 object detection. You can just open this, and you can just go in code.py and copy the raw file from this button. So what this will do, this will copy the whole code, and you can just simply paste it in your Raspberry Pi. So now let's just check it. Yes, so the write was successful. Now we can remove our SD card. So I'll just click on continue. I have removed the SD card, and now I'll just put the SD card into my Raspberry Pi. You can see that it's inserted. Now I'll connect the power. So you can see that the Raspberry Pi lit up, and so there is no lights or any indicator on this camera to know if it's working or not. And now after it turns on, uh, you can just find the IP of this Raspberry Pi using Angry IP scanner, or you can do what I'm doing. Go to your browser, then 192.168.1.1. So this is the web interface of your router. Now here is the password. You can just find the password behind your router, and then now what we have to do is click. You can just go on via LAN, like here, and you should see a Raspberry Pi. Yes, so Raspberry Pi here. Here I can see Raspberry Pi. The IP is 192.168.1.69. So now I'll open command prompt, and now I'll write SSH pi. So here I'm writing pi because I chose the username pi. You have to write whatever username you chose, pi at the rate. Then now I'll put the IP 192.168.1.69. So next it will, okay, so if this page is showed, then you can just click on Windows and Windows R. uh, Wait a minute, like my Windows is not working, so I am using Control and Escape. That opens the start menu. So what you can do is you can go to C, and then you can search for .ssh. So this will be a folder in your PC, and whenever you SSH into any device, it creates a file named as remote host or old host. Like you can see, this is the path. This is the path. So I'll just copy this path and paste it here. Okay, so this didn't work. Let me just go and do that manually. Users, nilab, and yes, here is the .ssh folder. So now we have to just delete the known host and known host old. We can just delete them, and we can just try it again. Now we'll be prompted for the password, and I chose the password as root, so I'll just type in root and press enter. Yes, so are you sure you want to continue connecting? Then we'll click on yes, and then it asked for password, and the password was root. It might take some time because it's the first boot. So as we can see, we have connected to our Raspberry Pi. So let's just start putting the commands which we have here. Okay, so now as this is done, we'll move on to the second command, which is this. So it will show you if it detects your camera or not. So I plugged out my camera just to show that this PCI slot. So I'll just disconnect the Raspberry Pi from the power. Or wait, let's do a more like sophisticated approach. Sudo halt. Okay, so now we can see that the light on this fan turned off. So now I can just plug it out of the power. Use a screwdriver to lift the brown lid on these PCI slots. Then just place the flex strip inside one of these PCI connectors. Okay, so now it is in place, and now let's just plug the Raspberry Pi back in and try SSH again. So now we should just see the password prompt where it will ask for the password of the Pi, and then we'll be good to go. Yes, so here it has asked for password, which is root. Okay, so I'll just type clear so that we have a more cleaner command prompt. Okay, so again we'll run this command. So it showed us this camera, so that means it has successfully detected my camera. Wait a minute. Yes, my camera. So now we can just start installing the stuff or the libraries which will need for our code to function. So this was already installed when I updated. Now we need to install these. Okay, so if you see this error like externally managed environment, then you have what you have to do is that you have to paste the command again, this command, and okay, wow, you have to paste this command again and then just type dash dash break dash system dash package dash dash break. uh, Wait a minute. So what do we have to write if that's not what it wants? Dash dash break. Oh, so I write package. It should be packages. Now I'll just click on enter. Oh, yes. Dash dash break dash system dash packages. Well, I don't see what's the problem right here. Let me just copy this command and paste it right here. If your Raspberry Pi lags, that's not a big problem. That is because of SSH. Okay, I guess we'll need to remove this dash y. Huh? I don't understand the problem right here. Let's just do this. Oh, ah, dumb mistake. So we can see that it was already installed. Now we can install OpenCV. And I have pasted, but this is lag, and this is normal. It is caused by SSH. Now I'll just hit enter and let it do its job. Okay, so now we'll be running the first camera test. So just hold the camera in front of your face. Or wait a minute, we can't run the camera test when we are in this command prompt. So we'll need to stop this, and then we'll be using a VNC server. So here I have real VNC viewer installed on my PC, and this is the IP of my Raspberry Pi. If it is your first time, then you can just go and type in your IP 192.168.1.69. Okay, so it will say that it's connecting, and then after some time it will show us the actual GUI of our Raspberry Pi, which is what we want. So oh yeah, we didn't enable the VNC server, so let's just SSH for the last time. So now we have to enable the VNC server. We'll just click on yes, and now it should show us the screen again, and it should say that VNC server enabled. Okay, so now we can see this. Now we can just press OK by tapping on enter. Now we can just go and connect to our real VNC viewer. So device identity verification failed. So we can just click on continue because we know it's our Raspberry Pi. We can go on finish, or we can just close this terminal. Okay, so this is our Raspberry Pi GUI. You can see the time is actually correct and everything's functioning. So now we can just paste our like latest command which we copied from the book which I have given. RPI cam dash hello dash t. Okay, paste. Okay, so now if I hit enter, it should show me the picture. Yes. So with this we know it's working, and now we can move on to our next part. So our next part will be creating the Python script and everything. So first of all we'll need to make a directory. So we'll be using the command which I have given in my workbook. That is SSH lag. I have already clicked on paste. So once we have made this object detection directory, now we can go on cd object detection. I press tab so that it auto fills. Now you can see the command is also given in this. Now we have to create a file in that directory. So now, like, again SSH lag, I have pressed the paste button already. Oh, finally paste. And now we should see an empty file. Yes, that's what we should see. Now let me head back to the workbook. This is the Python code which you can copy from my GitHub repository. I'll leave the link below in the description. Now we have to paste this code in this file. Attempting to reconnect. Okay, it's fine. What is the problem here now? Then paste. I don't know why am I not able to paste, although I can type, but I can't paste it. Let me check if I have copied it correctly. Yes, it's copied and everything's fine. Okay, so let's just again, this is for this is for sure the last time. sshpy@192.168.168.1.69. Okay, so root. Now we again have to go in this directory. Okay, this is not what we want. This, yes. So we are in this directly. We can just copy this command, we can paste it here. SSH lag again. And yeah, if you'll be using an external monitor which is connected to your Raspberry Pi, you'll definitely save some time because there won't be any SSH lag in that case. Okay, so is being edited by Pi with yes, because it is showing this because we are also on the same file on our VNC viewer. So we can just go on yes, and now here we can and now here we can paste the code. The wrong place again. It's the SSH delay. And yes, we have pasted the code successfully. We can just press Control and X, Control and X, and then Y, and then enter. So what this should do is bring us back to the home screen. Now we can just do python. Oh, so now we have to go on this our VNC viewer, open the terminal, go to cd object detection, and then we can just run the script using the command python 3 lag python 3 object detection.py, and no module. Oh yes, so we'll need to download some of the modules. Okay, I haven't written that here, so let's just go and search for the model chrome ultralytics py ultralytics. You can just copy this. Don't worry, I'll put all the links in the description. You can just go and run them from there. Dash dash break dash system dash packages. And hopefully after this we should be able to run our object detection using the camera. Or we might need to install some extra libraries, python libraries. It's just downloading everything, and then it will take more time to install, or it won't install. Okay, so after we run that command and everything's installed, we'll need to reboot the Raspberry Pi. Actually, I was not able to record due to a power cut. So now as we proceed, I have again connected to my Raspberry Pi. Now I'll open the terminal, we'll go to cd object detection. Okay, so now we'll ls. So here we have an object detection py. We have to run this file. Don't worry about these files. So python 3 object detection.py, enter. So now it will download the model. So as you can see, the camera is up and running, and here we have another yes, so now we can see the squares. Yes, we can see that it is detecting clock right here. Yes, the clock, and it is also detecting the chair. Wait a minute, what if I show him this? What is this? Why can't it detect it? I guess remote, yeah. So it is actually a remote. You can see this is actually a remote. So it's I don't know why it's showing as a cell phone. But okay, I'll just use it like this then. Remote, yeah. So teddy bear. Why is it considering this as teddy bear? Why is this considering as traffic light? But yeah, so if we take a closer look to this, we can change the models in the Python file. So this is our extra large model, this is the large model, and this is the medium model. Right now I'm using the small model because it's very slow. But if you are watching this video in future and like Raspberry Pi 6 has released and you are having Raspberry Pi 6, then you can go for or for this extra large model or large model. Or what we can do is we can overclock this Raspberry Pi and then we can run these models. So maybe we'll leave that for another video, and I'll provide you with the PDF and the code. You can check the link in the description, and here we have some troubleshooting guide also. Okay, so you can check these also if you have any error, or if the error is not fixed from this troubleshoot guide, then you can also comment it. I'll reply and I'll try to fix your problem. Thank you.